All right, welcome there, function folks. Lesson 1.9 on solving polynomial equations. And today's a pretty big day, except for the fact is that we've been doing this. The stuff today that we'll cover, we've been doing in other spots of the chapter. We're actually have moved into the next chapter, which I believe is chapter 4 in the book. And because we're moving into a new chapter, there's actually a few things that we want to think of, and I'm going to steal about 20 minutes of class time to do an activity. So keep that in mind. Today we're going to steal some of your class time to do an activity. This 3-minute review, it's kind of hard to understand what you're supposed to do, but let me explain it, and then you can pause the video and give it another go, then we'll take it up. So the idea here is there are different math things, an expression, an equation, and a function, and there are different things that you can do. So for instance, if you're expanding something, or if you're solving something, if you're graphing something, which of these things are you working with? Right? And then a linear example and a quadratic example. Well, a quadratic example, remember, has a squared on it and a linear doesn't. So what I would do now, pause the video, try and fill this in, maybe in pencil or use half, and then I'll take it up here momentarily. So give it a go. All right, hopefully you gave that a go, and now I'm going to fill it in. So what sorts of things do we do to expressions? Well, this is what we were working on in the last chapter. We can factor expressions. We can expand. We can, simplify. By that, I mean collect like terms, that sort of thing. Factoring and expanding might be simplifying. Collect CLT, collect like terms. We could substitute into an expression. Or evaluate, right? That's when we evaluate an expression, that's what we do. We substitute into it and evaluate, and that sort of thing is an expression. So what does an expression look like compared to an equation and a function? Well, an expression might be something, a linear expression, it's got no squared on it, so it might look something like this. Well, what sorts of things could we do to that expression? Well, we could factor it. We can't really simplify it because there are nothing that we can do it. We could substitute it into an evaluate, right? Substitute when m is 1 and m is 2 and m is minus 81.3 or whatever. Other linear examples, and this is kind of like grade 9 stuff, was linear expressions, right? We did lots of linear expressions in grade 9. So this sort of thing, well, what would we do to it? We could simplify it by expanding and collecting like terms and so on. A quadratic example of an expression, notice what makes this expression is there's only one variable and no equal sign. As long as there's no equal sign, it's an expression. And so a quadratic would be something like this, right, from grade 10, quadratic expression, or this one, right, another quadratic expression. It's like this. And the things that we can do to these ones are right here. An equation is when we've got an equal sign where the left side and the right side are both expressions. What do we do to equations? About the only thing that we do to an equation is solve. We solve them, right? So a linear equation might be something like, 5m plus 10 equals 20, or we could have, this sort of thing, linear equations, where each side is an expression. For quadratics, this is like grade 10, right? Solving grade 10 quadratic equations, right? Where each side is an expression. The maximum degree is 2 for a quadratic, and that's what we do for equations. Functions. What do we do with functions? Well, we graph them, right? Mostly that's what we do, is we graph them. That's the big thing. But we could do other things, like we could find the intercepts. If we wanted to do, we could find, that's my dog. Apparently somebody's at the door. Either that or he's just paranoid, and he is a little paranoid, my dog. We could find the minimums and maximums of a function, etc. But mostly we just graph it. A linear example, what would be a linear function? A linear function would be, something like this. Y equals mx plus b. Or back in grade 10, a cost function, something like this, where we've got two variables. We could graph that if we wanted to. It's so on. Quadratic, this is a parabola, right? And we could graph that parabola, or whatever. What's the point of this? Well, expressions and functions we talked about a lot in the unit so far. We factored polynomial expressions, we substituted into and evaluated polynomial expressions, we graphed polynomial functions, and we found intercepts, and we haven't found rate of change yet, but guess what, that's coming, and so on. So we've done this and this. This chapter, chapter 4, is about this one, and that's what we're talking about today. But as we'll see, it's kind of review. We've kind of done it already, and in fact, part of the in-class activity is you talking about expressions and equations that you've solved already, and also leaning on the expressions and function stuff that you did so far in the chapter. So the in-class activity is really a review activity. Let's get on with today's lesson, though. Here we go, solving polynomial equations. Solve polynomial equations using various strategies. Now, notice this is a little different than what we've seen. In chapter 3, just to drive home this point, we've seen the question factor something like this, right? Blah, blah, blah. We've also seen the question, this would be a question. We've also seen the question graph this. But we've never seen, by the way, that's expressions and functions. We've never seen just a plain old solve. But we have, haven't we? When we found the x-intercepts, we solved the equation when y was equal to 0, didn't we? How did we do that? Well, we need to factor this side. If I call that f at x, I want to factor f at x. And how do I do that? Well, I have various strategies for factoring this. And in this case, I have to use the factor thing. So I'm going to try and find a factor that makes this, when I substitute it into it, makes it 0. So factor that. Use the factor theorem. Notice f at 5, and we, I'm going to 105. I realize is big. We got to try a bunch of different things. We try 1 and 3 and 5 and -1 and -3 and -5, and whatever one you find, that's fine. When I tried 5, it works. And so instead of me going through the process a whole bunch of times, I'm hoping you'll trust me. And then what's the next step? Do you remember what the next step is after doing and finding a factor? This is equal to 0, so I say therefore x minus 5 is a factor. Remember what the next step is? Long division. We've done this, right? When we were factoring. Now it's equal to the left-hand side here, but we'll have to see how that changes our whole process. It doesn't really, not much. So long division, it's supposed to be cubed. There we go. The term that we're looking for, 3x squared, will make it so that when we subtract, the 3x cubed is gone. Watch your signs. Subtract, and down, off to the races, blah, 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 right? And hopefully you're doing this on your own and then just checking. That's the best way to do it because you're practicing. 10x, and when I subtract, this numbers aren't very nice here, but -31 subtract -10 is -21. The 105 comes down. Remember, it's got to work out, otherwise I goof something up. And indeed, it does work out. Awesome. So what do I say? Well, what does this mean? This equation, I'm going to call it star, just so I don't have to write it out again. Star becomes the divisor, the factor, times this equals 0. And so notice, one of the solutions to my equations is x equals 5. I can see that already. But also, notice that I've got a quadratic here, and I can factor it, right? I can make this into two brackets. Or if you're scared, you could use the quadratic formula, right? One of the two F words, factor or formula here. So this factors into, I find, and you know, if you have trouble factoring this, I don't know what strategy you learned in grade 11 for factoring these trinomials, but maybe just guess and check. You know, there's not too many things that this is going to be 3x here and x here. It has to be, and then you can just mess around until the numbers work out. Would be one way to do it, or you could use the quadratic formula. I know I use something that's called the box method. I'll show you how that works over here. And I need numbers that multiply to get 63. Maybe I showed you this already. Yeah, I think I did. I had to get 2. What are the numbers? Are 9 and negative 7. 9 and negative 7. Factor up. Factor up. Factor across. There are my factors, x plus 3 and 3x minus 7. Whatever technique that you have to factor trinomials, you go ahead and use it. And again, notice that you could have used the quadratic formula there. We have a quadratic formula question coming up soon. So there's the factored version. Now what are the solutions? Well, each of these brackets gives me a solution to the equation. This one is a little tougher to see. So therefore, the solution set is, and there's 3 of them, solution set is equal to 5, 7/3, and minus 3. And those are the solutions to that original equation. Notice, just in passing, that this feels like what we did when we were asked to graph that. If we wanted to, and this is a thought cloud, you don't have to write this down. If we wanted to graph that expression, or graph that function rather, minus 13x squared, what's the rest? Minus 31 positive. If I want to graph that, the first thing I would have done was solve that equation and found these x-intercepts. So what this tells me is at minus 3, 7/3, and 5 are all linear roots, slash roots, and then I could get, you know, that they're connected, aren't they? The skills are connected. Factored the left side, which is factoring an expression, gave me the solutions to an equation, which also allowed me to do the graph. And so nothing surprising here. All right, we only have one more example and a little tiny exercise, but that's coming up in part 2.